Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts. Here's Daniel's prompt.
Hi there, Herman and Corn. So it amazes me sometimes to think how many different technologies have matured greatly over the last couple of years, and they're all kind of bucketed under AI can do everything now, but they're really kind of very separate fields of technical enterprise. And one of those is optical character recognition, or OCR. So as your average kind of, Linux using techie, I played around with OCR for quite a bunch of time, and I'd actually put it in kind of the same bracket as speech tech, which I also played around with a bit over the years and was never really that impressed by what was available. And it wasn't good enough to kind of say, oh, this is an extremely useful thing that I can actually get a lot of value from. OCR, at least the packages I used over the years, was kind of, generally accurate, but had sometimes, you'd get these kind of random failures, and just enough that when you're trying to get something like this, that you just want it to be very, very robust and set it and forget it, that even that kind of 10 or 20% of characters you need to manually correct kind of makes the whole thing not worth your time. With the advent of AI models and the transformer architecture that we've talked about underpinning stuff like ASR and conversation bots and generative AI, we've seen vision language models, or VLMs, deployed as OCR tools without really anyone, I think, batting an eyelid and saying, hang on, have we just displaced an entire category of technology? So that's what I'd love to get into in today's podcast. OCR might seem like a bit of a dry and dull topic, but is gigantically important in digitizing text, making printed text available, business workflows, massive application for it, processing, any and all text. And as you know, we live in Israel, Herman and Corn, and there's always been quite a bit of interest in OCR for Hebrew, for this language, and some good models. So just curious to know a few specific questions, I guess. My impression has been that I've been using these locally. I've been using just general vision models, stuff like Qwen 3, the Gemini series, and the beauty of these models for multimodal processing is that I can, you can prompt anything and say, with a system prompt, your task is to extract exactly these entities from text, return them in a structured output, and define it pretty precisely. I haven't seen or felt any need for an OCR fine-tune or an OCR specific AI model. But I'm just curious to know, are they out there? Because I do see API specifically for OCR. But I also kind of feel, do we actually need these things anymore? Has it been displanted? And I always love to know and think about the lineage of the technology. So it's clearly come on a lot with, this is little Ezra you might be hearing in the background. He's reacting unusually strongly against OCR. Someone has strong feelings about it. What was it that the tech was at before? It didn't just come out. It's been a long-standing field of endeavor, and I'd love to know a little bit about how that evolved and how AI has improved it quite significantly. And is it perfected? I mean, can we just say, yeah, we kind of pretty much have failure-proof OCR, chapter closed on, getting computers to recognize text? Over to you guys.
Welcome to my weird prompts. I am Corn, and as always, I am joined by my brother,
Herman Poppleberry, at your service. It is a beautiful day here in Jerusalem, although I have been cooped up inside, reading about the latest benchmarks for multimodal models.
Well, that is actually perfect timing because our housemate Daniel sent us a fascinating audio prompt this morning. He was asking about something that has been a massive pain for developers and businesses for decades, And that is Optical Character Recognition, or OCR.
Oh, OCR. The classic computer science problem that always felt 90% solved, but that last 10% was an absolute nightmare. It is one of those technologies that people just assumed was a solved problem because we have been doing it since the 1970s, but anyone who has actually tried to use it for anything complex knows how brittle it used to be.
Exactly. Daniel was pointing out that with the rise of transformer-based vision language models like Qwen and the Gemini series, the way we handle text extraction has completely shifted. He wants to know if specialized OCR models and APIs are even necessary anymore, or if general multimodal AI has just, well, eaten that entire category of software.
It is a great question, and honestly, it is a bit of an existential moment for a lot of companies that build their entire business model around proprietary OCR engines. Here we are in January of 2026, and the landscape looks nothing like it did even 3 years ago.
I want to dig into that evolution, but first, let us set the stage. For the listeners who maybe have not spent their weekends wrestling with Python libraries, what was the old way? Why was OCR so notoriously unreliable?
So, the traditional approach was very much a pipeline of many different, very specific steps. You would start with image pre-processing. Things like binarization, where you turn the image into pure black and white and deskewing to make sure the text was perfectly horizontal. And then you had character segmentation, where the software tried to figure out where one letter ended and the next began.
Right. And if you had a smudge on the paper or a slightly unusual font, that segmentation would just fall apart.
Precisely. It was mostly pattern matching. The computer would look at a blob of pixels and say, this looks 85% like a capital letter A. But it had no idea what it was actually reading. It had no concept of language or context. If the word was apple but the P was slightly blurry, the OCR might tell you it was AQL, and it would not see anything wrong with that because it was not reading the word apple. It was just matching shapes.
And that is why we ended up with those massive manual correction workflows. I remember seeing jobs advertised for data entry clerks whose entire role was just fixing the mistakes the OCR made on scanned invoices.
It was a huge industry, and even when we moved into the deep learning era, maybe around 2015 or so, we started using convolutional neural networks and long short-term memory networks. That was a big leap because the models started to understand sequences of characters. They could use a bit of a language model to say, a Kukili is a bit of a language model to say, a Kukili is a probably apple. But it was still very limited.
But now we have these vision language models, and the experience is totally different. I was playing around with a receipt the other day using a newer model, and I did not have to define any boxes or pre-process the image. I just uploaded the photo and said, tell me the name of the store and the tax amount, and it just did it perfectly.
That is the transformer revolution in action. These models, like Gemini 1.5 Pro or the latest Qwen 2.5 VL, are not just matching shapes, they are multimodal from the ground up. They are seeing the image and understanding the text within the context of the entire visual scene. They know what a receipt looks like. They know that the number at the very bottom, usually next to the word total, is likely the final price. They are using their massive internal knowledge of how the world works to inform their character recognition.
It feels like the difference between a person who only knows how to trace letters and a person who can actually read the book.
That is a perfect analogy. And because they are generative, you can ask for structured data. You do not just get a raw string of messy text. You can say, give me this in JSON format, with keys for vendor, date, and currency. And because the model understands the schema of JSON and the content of the image simultaneously, it bridges that gap that used to require thousands of lines of custom code.
So if these general models are so good, does that mean the specialized APIs are dead? I mean, companies like Amazon and Google have spent years and millions of dollars on things like Textract and Document AI. Are those becoming obsolete?
Well, that is where it gets interesting. Before we dive into the business implications and the specific challenges of languages like Hebrew, let us take a quick break for our sponsors.
Good idea. We will be right back.
Are you tired of your thoughts being too loud? Do you wish you could just turn down the volume on your Nardior? Time-painted LiveMind silence technology, the Muffle Mind creates a localized vacuum of sound right around your cranium. It is perfect for family gatherings, busy offices, or when you are just tired of hearing your own internal monologue remind you about that embarrassing thing you said in 3rd grade. The Muffle Mind helmet is heavy or, might mind silence heavy, do I operating heavy who are swimming, but keep me he's cat it.
All right, thanks, Larry. I am not sure I want a lead-lined helmet, but I suppose there is a market for everything. Anyway, Herman, back to the topic. We were talking about whether specialized OCR APIs are still necessary in a world dominated by vision language models.
Right. And the answer, like most things in tech, is it depends on your scale and your budget. If you are a developer building a small app that needs to process 10 invoices a day, using a general vision language model via an API is a no-brainer. It is flexible, it is easy to prompt, and the accuracy is incredible. You do not need to train anything.
But what if you are a massive bank processing 10 million documents a month?
Exactly. That is where the specialized APIs still hold a lot of ground. There are 3 main factors here: cost, latency, and throughput. General vision language models are huge. Running a prompt through something like Gemini or a large Qwen model is computationally expensive. If you are paying per 1,000 tokens and you are processing millions of pages, that bill is going to be astronomical compared to a specialized, highly optimized OCR engine that only does one thing.
So, efficiency is still a meta factor. A model that only knows how to read characters is going to be much faster and cheaper than a model that can also write poetry and explain quantum physics.
Precisely. And then there is the latency. If you need real-time extraction, like scanning a credit card in a mobile app, you cannot wait 3 seconds for a massive cloud model to process the image and send back a response. You need a small, fine-tuned model that can run locally on the device. Those specialized models are being distilled down to a size where they can run on a phone with almost zero lag.
That makes sense. But what about the accuracy and the structural understanding? Does a specialized OCR model know how to handle a complex table as well as a vision language model?
Historically, no. Tables were the absolute bane of OCR. Trying to reconstruct a table from a list of coordinates and text strings was a nightmare. But what we are seeing now is a middle ground. The specialized APIs are incorporating transformer architectures. They are becoming mini vision language models that are specifically fine-tuned for document understanding. They might not be able to tell you a joke about the invoice, but they are becoming much better at understanding the hierarchy of the data.
I want to talk about the Hebrew aspect that Daniel mentioned. Living here in Jerusalem, we see this all the time. Hebrew is notoriously difficult for traditional OCR. You have the right-to-left script. You have characters that look very similar, like the letter Vav and the letter Zayin. And then you have the vowel points, the nikud, which can really mess up a pattern-matching algorithm.
Oh, Hebrew OCR was a disaster for the longest time. I remember trying to digitize some old family documents and the results were just gibberish. Part of the problem was just data. Most of the early OCR models were trained on Latin scripts. Hebrew was always an afterthought. But vision language models have changed the game for low resource or complex scripts.
Is that because they're trained on such a vast amount of diverse data that they just pick up the nuances of Hebrew naturally?
That is part of it. But it is also the way they understand the language. Because these models have a deep internal representation of Hebrew grammar and vocabulary, they can disambiguate characters based on the surrounding words. If the model sees a character that could be a vav or a zayin, but the word only makes sense with a vav, the model will pick the correct one. It is using its linguistic intelligence to correct the visual ambiguity.
That is huge for digitizing historical archives. I know the National Library of Israel has been doing a lot of work in this area. Being able to take a newspaper from the 1920s and turn it into searchable, structured text with high accuracy is a massive win for researchers.
It really is. And it is not just the text, it is the layout. Old newspapers have these crazy layouts with columns and advertisements and overlapping images. A traditional OCR engine would just get lost. A vision language model can look at the page and say, okay, this is a headline, this is a 3-column article that continues on page 4. That level of semantic understanding is what makes the technology feel solved for the first time.
You used the word solved. That was one of the things Daniel asked. Can we actually consider OCR to be solved or failure-proof now?
Solved is a strong word. I would say it is solved in the sense that the ceiling of what is possible has been raised so high that for most common use cases, the friction has disappeared. But failure-proof? Absolutely not.
What are the failure modes for these modern models? If it is not just blurry text anymore, what trips them up?
Hallucinations are the big one. This is the dark side of using a generative model for OCR. A traditional OCR model might give you a symbol it does not recognize, like a little box or a question mark, but a vision language model wants to be helpful. If it sees a blurry number on an invoice, it might just guess. It might turn a blurry 3 into an 8 because it thinks an 8 makes more sense in that context. In a financial or medical setting, that context and hallucinations is much more dangerous than a simple recognition error.
Right, because you might not even realize it made a mistake. If the OCR says it cannot read a field, you check it. If it gives you a perfectly formatted but incorrect number, you might just process it.
Exactly. And then there is the issue of complex reasoning. If you have a document with very dense overlapping text or handwritten notes in the margins, the model might get confused about the reading order. It might combine a note from the margin into a sentence in the main body of the text. We also see issues with very long documents. Even with the massive context windows we have in 2026, processing a 100-page legal document and maintaining perfect accuracy on every single target is
So, what is the practical takeaway for someone looking at this technology today? If I am starting a project that needs to extract data from documents, what is the move?
My advice would be to start with a general-purpose vision language model. Use something like Qwen VL or Gemini to prototype. It will get you to 95% accuracy in an afternoon just by writing a good prompt. You can define exactly what data you want and what format you want it in. It is the fastest way to prove the concept.
And then optimize later if you need to.
Right. If you find that your API costs are too high or you need it to be faster, then you look into fine-tuning a smaller specialized model, or you look at the specialized document APIs from the big providers. They are increasingly offering the best of both worlds, the speed of specialized engines with the intelligence of transformers.
It feels like the role as the developer has changed. It is less about writing image processing code and more about prompt engineering and validation.
Definitely. The focus has shifted from recognition to verification. You need to build systems that can spot those hallucinations. Maybe you use 2 different models and compare their outputs, or you use a smaller model to double-check the critical fields. The human-in-the-loop part of the process is not about typing in the data anymore. It is about auditing the AI's work.
That is a much more interesting job, to be honest. It is more about quality control and system design than just brute force data entry.
It is. And it opens up so many possibilities. Think about all the unstructured data that is just sitting in file cabinets or old databases. We can now unlock that data at a scale that was unimaginable 10 years ago. We can analyze trends in historical documents. We can automate complex business workflows that involve multiple types of forms, and we can do it in almost any language.
It really is a paradigm shift. I think back to how frustrated we used to get just trying to scan a tax form, and it feels like we are living in the future.
We really are. And the fact that we can do this with open-weight models like Qwen means that this technology is not just locked away behind the big tech companies. You can run these models on your own hardware, keep your data private, and still get world-class results.
That is a great point. The democratization of this tech is just as important as the raw performance.
Absolutely. Well, I think we have covered a lot of ground here. From the brittle pattern matching of the past to the multimodal intelligence of 2026.
Definitely. Thank you, Daniel, for sending in such a thought-provoking prompt. It is always fun to look at a technology that we take for granted and see just how much it has evolved under the hood.
It really is. And if any of our listeners have their own weird prompts or topics they want us to dive into, please get in touch.
You can find us on Spotify and at our website, myweirdprompts.com. We have a contact form there and an RSS feed for all you subscribers.
This has been My Weird Prompts. I am Herman Papaberry.
And I am Corn. Thanks for listening, and we will see you next time.
Bye everyone. Stay curious.
And keep those prompts coming. We love a good deep dive.
Especially if it involves lead-lined helmets.
Speak for yourself, Herman. I will stick to the software side of things.
Fair enough. Until next time.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.